So this question here has been getting a lot of questions, and it's been getting questions from students who don't have a clear understanding of the object-oriented programming model. So I'm going to go over the details of that. And so we start out with line number 1. We're importing math, right? This is the compiler. I'm talking about the control flow. Line number 1 imports the math file. Line 2, nothing there. Line 3, this is a class definition for class point. And the compiler treats class definitions just like it treats function definitions. It ignores them until they're called, right? So function definitions need to be called, and in the case of a class, it is not run until an instance of the class is created. Okay, and that's happening right here on line 25. So okay, so this is a class definition, and a class definition, the analogy that I like to use is that it is a two-dimensional blueprint. It's a two-dimensional piece of paper. It's a blueprint for how to create an object of type point. Okay, and so the way that I think about it is a blue piece of paper with drawings of how to build a house, right? And then what does the architect need to do? He needs to take that piece of paper and then go out and put together the house using wood, a three-dimensional object on top of a hill, right? So that's what this is. This is just a blueprint for a point. And so yeah, and so how do we actually make a point? The way we make a point is we say the name of the class, we give it the 2 parentheses, and we set as arguments any information that's needed by the constructor. Okay, so notice here that when you're defining a class, we use a capital P. Never do you ever see a capital letter in Python except for the names of classes, and that's purposeful, right? So when you're in your code and you see capital P, you will not mistake it from a function name. It's not a function name, right? Automatically, you should be able to see this and say, hey, that's not a function name. That is a class definition, right? So when it gets to here, it's going to jump up to class point, and it's automatically going to run the constructor. This init method is called the constructor. So let's do that. Yeah, and so what does it do? It constructs the object. This is like right here, building the house. Okay, and what is an object of class point? An object is a collection of variables, right? So we have one variable here, like x is equal to 5, but sometimes we need a collection of variables, like x, we need y, we need z, we need color, we need width, length, height, name, right? So all of these things. So the object-oriented programming model is saying, okay, well, if I ever need a collection of variables, make a class for it. Okay, and these definitions here, right, are not function definitions. We call these methods. And they can be called to change the value of these collection of variables. Right? So a point is the simplest class that can possibly be created because it consists of only 2 pieces of data. It consists of an x and a y. It consists of an x and a y. The point is dimensionless, so it doesn't have a width and a height, right? It's dimensionless, so it doesn't have a color. So, if a variable is one piece of data and a class is a collection of variables, then the simplest class that we can make is a point because it contains 2 pieces of data, 2 variables, and that's what we have here. We have x and we have y. Okay. So one thing that you might be confused about is like, hey, wait a second, there's 2 arguments here. We have a 3 and a 3, and we have 3 parameters up here in the constructor, right? We have self, init x, and init y. Well, the self is just always there, right, in all of the methods. You see here how we have self, 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 and self as the first argument. So that doesn't count, right? When we look at this, what we should see is, okay, the constructor takes in two pieces of data, an x and a y. What is the self? The self is the object that is being created. Okay, so it is the point that we're creating. And so why do we have self.x right here? Right. Well, this variable could very well be any name, right? And it could also be x and y. So if we have x and y and we don't have the self, then it's a little bit ambiguous, right? Which x are we talking about here that's going to be equal to x? Is it this x up here, or is it the instance variable x? So whenever you're talking about the instance variable, you always need to say self. Okay, so self.x, self.y. And so now after it completes executing the constructor, it's going to jump back here to line 25, and it's going to put the object that contains an x and a y into the variable called p. So the way that I like to think about it is the p is a burlap bag. It's a big sack of potatoes, and it has the name p on it, right? And if you look into that burlap sack, you'll see variables in there, right? Not just one variable, but variables, because this is an object. And so what would we see? We would see an x variable that's equal to 3, and we would see a y variable that is equal to 3. All right. And then what we're doing on line 26 is we're running the constructor again, and we're creating another point. We're getting another burlap sack. We're putting the label Q on the front of that one. And if you look into that burlap sack with the label Q on the front, it's going to have an x variable in there that's equal to 6. It's going to have a y variable that's equal to 7. All right. And if I go ahead and run one of these methods, the result of the method is dependent on which object I am calling it from, right? Because like this getX method, let's take a look at it, right? What is it doing? It is returning the x instance variable. It's returning the x instance variable, right? So if I call it using the p object, it's going to return 3. If I call, when you call methods using a class, the vocabulary term is invoke, right? So when I invoke getX using Q, it's going to return 7, right? So we can prove that right here. After making P, we're going to say P. That's the object that I want to call, or that's the one that I want to run the method. So I say P.getX, right? And that's gonna jump up here, and it's going to return the value of the instance variable x of the p object, right? So if I want to see anything, I got to print that out, or print the return value of that method, right? So if I come over here and I run it, I got the 3 right here, okay? And then if I run it again using Q, then it is going to return the 6. And so what is exactly happening here? Well, when we print, it needs to evaluate this expression. So it gets the burlap sack with the P label on the front of it, and it's going to run this method. Jumps up here, says, okay, return the instance variable x. So I'm going to open up that burlap sack, take out the x, look at what's inside of it. There's a 3 in there, and I'm going to return that value 3. And this expression gets replaced with the value 3. And that's why 3 is printed out on the screen. And that's the same reason why 6 is printed out on the screen on line 29. All right, so that's that. And then we get to the point where we need to talk about distance from point, right? So distance from point, we're saying the first point, run distance from point to the argument that we're passing it, which is a second point, right? So we're basically saying run this method using P and give it Q, because we want to find the distance from P to Q. So then when it jumps up to line 20, right, self is equal to the object that is calling distance from point. So which object is calling distance from point, or invoking distance from point? It is P. So self is P, and Q is other P. Okay, and so this P, or this self, represents two variables, an x and a y, right? The other p represents two other variables, a second x and a y. And that's all the information we need to calculate the distance between the 2 points. Right? So what's the method that we're going to use to calculate the distance from one point to another point? Well, you want to think about it as a triangle, and we need to use Pythagorean theorem to calculate d from one point to another point. And so what do we need to do? We need to take q's x and subtract p's x from it. And then we need to take q's y and subtract p's y from it. And that way we will get the base of the triangle and we will get the side of the triangle. Right? So if we have the base and we have the side, we can use Pythagorean theorem to figure out what is the hypotenuse. And the hypotenuse of that triangle is the distance from point A to point B, point P to point Q. Right? So that's what we're doing here, right? So dx is a term from calculus. It refers to like differential x, I believe. The way I like to think about it is difference in x, right? And that's what we're using here is difference between the two x points, right? So what are we saying here? Other p. Well, what is other p? Other p is here, right, as an argument to distance from point, and that is the q point. So other p represents the 6 and the 7. And what are we running on it? We're running getX. So that is going to give us the 6. Right? So this gets replaced with 6. And then self is the p, right? And so p's x is going to be 3. So the result of this is going to be 3, and that is the base of the triangle that we're trying to form. And then we're going to run other p, which is q.getY. And so it's going to open up the bag of variables that are represented by the q object, and it's going to get the y, which is 7. So it's going to replace this guy here with 7. Self.y is 3, and dy is going to be equal to 4. Right? So the base of our triangle is 3, the height of the triangle or the side of the triangle is 4, and since we have the base and the side, we can calculate the hypotenuse, right, using Pythagorean theorem. And how does that happen? Well, we need to take the square root of a squared plus b squared. Right? So we do a squared plus b squared, and then we take the square root of that and we return that value. So then that value gets replaced. This expression gets replaced with the length of the hypotenuse, and it prints out to the screen. Okay. So that's basically what's going on here. So let me return all of this, and I'll run it. It prints out 5, right? And what about if I change this to 17 and 16? Well, then this value is going to grow bigger because of all the calculations that need to take place, and the hypotenuse is going to be that these 2 points are going to form a bigger triangle with a bigger hypotenuse, and that's what we get. Right? So hopefully that made sense, and if it didn't, come on up and I'll draw it out and we'll work this out together.